Welcome to Romeo Maths and Science class. Today we want to look at the topic mole concept in chemistry. We'll be looking at some mathematical formulas that we can use to do calculation under mole concept. All right, let us look at some few formulas here. From the definition of molar mass, where we say molar mass is the mass of 1 mole of any substance. So mathematically, we say molar mass is equal to the mass of the substance, as we can see here, divided by, that is, amount of substance, all right, amount of substance into bracket small n. That is the symbol, as you can see. Then we can say that molar mass is equal to mass over what? Amount of substance, which is what? N, as you can see here. All right, from here we can make n the subject, which represents amount of substance, as mass over molar mass. All right, and we can also have our mass of the substance as molar mass, all right, multiplied by amount of substance. Don't forget that our molar mass is measured in gram per mole, all right? So that is the unit that we use. And again, our amount of substance is also measured in mole. In short, we can write MOL, as you can see. And the last one, our mass is measured in what? In gram, as you can see on the board. So these are some units that we can use in our calculation. All right, let us also look at Avogadro's number, or we say Avogadro's constant, all right? Now, when we say Avogadro's constant, we say is the number of particles present in 1 mole of any substance. And mathematically, Avogadro's number is equal to number of particles, as you can see here, into bracket NP, as you can see, divided by amount of substance, all right, as you can see here, to bracket N. Then we can say L should be equal to NP all over what? N. So we can also have this formula to do calculation. Again, we can make N the subject. And when we make N the subject, which is amount of substance, we are going to have number of particles divided by Avogadro's constant, all right? Again, we can make number of particles the subject from this formula, which is going to be Avogadro constant times what? Amount of substance. Don't forget that Avogadro constant is a number which is constant and is given at 6.02 times 10 raised to the power 23 particles. So this number is constant, as we can see here. And again, our mole, the unit or the amount of substance, the unit is already mole, as we can have here. All right, let us proceed to what we call concentration. All right, there is a term called concentration, or we can call it molarity, all right, in mole concept. And when we say concentration, we say that is the amount of substance dissolved in 1 dm cube of a solution. And mathematically, concentration or molarity is equal to amount of substance, all right? Amount of substance, as you can see here, into bracket N, all over volume, all right? All over volume. And our volume must be in dm cube. That is decimeter cube, all right? And the symbol is what? V. So from here, we can say that C should be equal to N over what? V, as you can see. So we can use this formula to do calculation under what? Concentration. Again, we can also say that mole or amount of substance should be equal to concentration times what? Volume. And we can also say volume should be equal to mole divided by what? Concentration. So from change of subject, we can have these formulas as you can see, sorry, here. All right. So volume will be equal to N over C, as we can see here. Don't forget that our concentration is also measured, that is in mole per decimeter cube. All right. Or we can also use molar, all right, into bracket capital N, to measure our what? Concentration, as you can see. And our volume must be in decimeter cube, as you can see. So don't forget, sometimes if the volume is given in centimeter cube, we can change it to what? Decimeter cube, by dividing it by 1,000. So let's say I give you a question and the volume is, let's say, 200 centimeter cube, and we want it in what? Decimeter cube. You just divide it by what? 1,000, so that your volume now will become 0.2 decimeter cube. So we must know our convention here. All right, let us proceed with our formulas. From concentration, which is equal to mole over volume, as we can see here, all right, and from this, from molar mass, we also studied that is mole should be equal to mass over what? Molar mass, as we can see. Now we can fix these values here, or this alphabet here, into this, as you can see here. Therefore, we can generate another formula as mass divided by molar mass divided by volume, as you can see on the board. All right. And breaking this down, we are going to have C equal to mass over what? Molar mass times what? Volume. So we can also use this formula for concentration, as you can see here. And from here, we can make other things the subject. We can make mass the subject, where mass will be equal to concentration times molar mass times volume. All right. And from here, we can also say molar mass should be equal to, that is mass divided by, that is concentration, all right, times what? Volume. All right. So here we can have so many formulas here as well. All right. Let us proceed to what we call mass concentration. Mass concentration. All right. Mass concentration. And we say mass concentration is the mass of a substance dissolved in 1 dm cube of a solution. And mathematically, mass concentration is equal to the mass of the substance divided by the volume, all right, in dm cube. Our volumes all are in dm cube, so we shouldn't forget about that. We can shorten it as mass concentration is equal to m over what? V. So this is the formula that we can use to do calculations under what? Mass concentration. Now, let us look at something here again, all right? Now, if mass concentration is equal to mass over volume, all right? And from this formula, where we have the mass of a substance is equal to concentration times molar mass times volume, as we can see here. Now, when we use this to replace our M, we are going to have mass concentration is equal to concentration times molar mass times volume, all over what? Volume, as we can see. And this will cancel this. Then mass concentration will be equal to concentration times what? Molar mass. So we can also use this formula for what? Mass concentration, as well as we can also use this formula. All right. All right. Let us proceed to what we call dilution. We can also have a formula in dilution. All right. And one thing we need to know about dilution is that in dilution, The initial concentration, all right, let me shorten it. Initial concentration, let's say C1, all right, times initial volume, all right, volume, initial volume into bracket V1 should be equal to what we call final concentration, which is C2, times final volume, all right, which is V2. So we can also have this as C1, all right, V1 should be equal to C2, V2. So we can also use this formula in what we call dilution. Anytime we dilute a solution, all right, the initial concentration times the initial volume should be equal to final concentration times what? Final volume. And we can be asked to find any of these quantities here, all right? So we can say C1 should be equal to, that is C2 V2 all over what? V1. We can also say C2 should be equal to C1 V1 all divided by what? V2. And also we can say V1, which is the initial volume, should be equal to C2 V2 all over what? C1. All right? And we can also say that V2 should be equal to that is C1 V1 all divided by what? That is C2, as we can see here. So we can make use of this formulas here. All right, let me get some few space here so that I can also explain something about molar mass here for us. Now, sometimes one thing about molar mass we need to know is that there will be some questions that we cannot use this formula to calculate molar mass. So we need to use a principle called formula mass. All right, formula mass approach. Let's assume I give you, let's say, relative atomic masses or numbers. N to be 23, all right, H to be 1, and oxygen to be 16. Then I ask you to calculate, let's say, the molar mass of sodium hydroxide. With a question like this, you cannot use this formula to calculate for the molar mass. So we need to use an approach here called the formula mass approach, where we are going to calculate our molar mass of sodium hydroxide as, now our sodium here is 23. So we just put our 23 there. Our oxygen is 16. We put our 16 there. And our hydrogen is 1, as you can see. So we sum them, then we add them, which will be what? 40 gram per what? Mole. So we can also use this approach to calculate what? Molar mass. All right, these are some few formulas that we can have under mole concept. In our next meeting, we are going to look at how we can use these formulas to do some calculation. Thank you. All right, the formulas that we studied, let's see how we can use it to answer the questions on the board. Thank you.